Good morning. This is Lavanya, Assistant Professor in Civil Department from Marri Laxman Reddy Engineering College. Today I am discussing about the building materials in the subject of building material construction planning. So today we are discussing about the building components. What are the building components? Lintels, arches, walls, staircases, types of floors, types of roofs, walls, foundations, damp-proof doors and windows. Building components are structural and functional elements comprising a building divided into substructure and superstructure. What is substructure? What is superstructure? Substructure is the below the ground level and superstructure is the above the ground level. Key components are include the foundation, plinth, walls, columns, floors, roofs, doors, and windows. So, which works together to ensure stability, durability, and safety. So, first thing, foundation, the lowest part of the structure that transfer the building loads safely to the soil. And next, plinth, the portion between the ground level and finished floor level, acting as a stabilizer and protecting from ground moisture. Next, damp proof course. It's called DPC also. A waterproof layer typically applied at plinth level to prevent moisture from rising into wall. Building components. So, superstructure. What is superstructure? Above the ground level is superstructure. First, we are talking about walls. Wall, vertical elements that divide the space and carry loads to the foundation. Columns and beams, the main vertical and horizontal structural members that support the roof and floors. So vertical members is called columns and horizontal members is called beams. And next, floor, horizontal platforms providing support to the occupants. Roof, the topmost covering protecting the building from weather. Lintels, beams placed over door or window opening to support the load above. Stairs, provide vertical access between different floor levels. So here, normally in our construction, practically we are used some dimensions. So like components, we have some standard dimensions. For what? For plinth in height 30, 45, 60, 70, 90 centimeters. Wall thickness, for wall thickness, loading bar 10 centimeters, 20, 30, 40 centimeters. Lintel thickness is 15 centimeters and sajja portions are 30, 45. Depends upon the structure type. We are decide the dimensions. Slab thickness 1 meter to 0.15 meters. Parapet wall thickness 10 centimeters. Parapet height 1 meter. Door width 0.8 meters, 0.9 meters, 1 meter, and 1.2 meters. This is also depends upon rooms, either master bedroom, main door, washroom, kitchen room. So depends upon the room dimensions we decide the door width and door height 1.8 meters, 2 meters, 2.1 meters. Seal height 0.07 to 0.1 meters. Lintel height 2 meters from the floor level. So 2 meters from the floor level means here this is a ground level, this is floor. 2 meters from ground level, lintel, it is called lintel. And next, column size. Columns are three types: square column, rectangular column, circular column. Square column 20 by 20 centimeters and 30 by 30, depends upon the same multiple floors we are constructed, they are required more length of the columns. And next rectangular 20 by 30 centimeters. Column footing 1 by 1 by 1 meter below ground level. Depth of the beam 30 centimeters, 45 centimeters, 60 centimeters. Steps. What is steps? Steps here, number of rises equal to height of ceiling plus slab thickness or riser height. Riser height to 15 to 20 centimeters. Thread width 25, 30, 35 centimeters. Width of the steps minimum 1 meter. Depends upon our space in our construction practice. So we required minimum length is 1 meter. We have more space, we can construct 2 meters, 1.5 meter also. Next, foundation. Foundation is the most important for the superstructure. Basic. A foundation in civil engineering is the crucial lower substructure that transfers structural loads. What are the structural loads? Weight, wind, seismic forces safely into the soil or rock, ensuring stability, preventing uneven settlements, and protecting against from the moisture. Foundations are broadly classified into shallow foundation and deep foundation. So next, types of foundation. Shallow foundation. In these foundations, shallow foundations are classified into 4 types of footings: isolated footing, stripped footing, combined footing, raft or mat footings are foundations. So isolated footings are supported individual columns. Uh, Wall footing support the long walls or closely spaced columns. Combined footing support are 2 or more columns when they are close together. A wrapped foundation is a large concrete mat supporting an entire building used on the soft soil. Deep foundation, uh, pile foundation, long slender member that transfer loads through weak soil to stronger, deeper soil or rock via friction, ending bearing. Pier foundation, hollow tubes are shaft sunk to the required depth, often used as a bridges. So here, look into this image. These are the types of footings images. First one, wall footing. Second one, simple spread footing, stepped footing, and sloped footing, combined footing. Combined means we have one floor construction, 2 columns. Strap footing, mat or raft foundation, pile foundation, drilled build, pier. These are the foundation types of foundation images. Next, doors and windows. Doors are removable barriers secured in wall opening to provide access and security between rooms to the exterior, while windows are opening in walls filled with transparent or translucent material, primarily providing natural light, ventilation, and vision. Both are crucial building components that facilitate climate control, privacy, and architectural styles. And next, windows. A window is a purposefully designed opening in a building wall fitted with a frame and sash intended to facilitate natural light, air circulation, ventilation, or outside visibility. They are essential for occupant comfort, energy efficiency. So here, door diagram. 4 panel diagram, 5 panel diagram, 6 panel diagram, double shutter panel door. So here, this is panel, top rail, freeze rail, panel, frame. It's called frame, bottom rail. This is fully glassed single shutter door. Means glass door. Single glass door. Here also same frame is called glass panel. So only frame is a glass door. And next partially glassed, partially panel double shutter door. Here half of the portion covered with the glass, half of the portion with covered with timber. So here also same frame, glass panel, timber panel. This is glass, this is timber. Floors and roofs. A floor is a horizontal structural element that divides building into different levels, providing a solid level surface for occupants, furniture, and equipment. It acts as supporting platform that transfers dead loads and live loads to wall. Columns are the ground, often offering damp proofing and insulation. A roof in civil engineering is the uppermost structural covering of a building, designed to enclose space and protect the interior from environmental elements like rain, sun, wind, and snow. It consists of a structural support system and waterproof covering acting as a crucial barrier to prevent deterioration from the top. So these are the types of roofs. Here open gable, box gable, dormer, hip, butterfly method. These are the completely different types of roofs. So uh, here cross hipped, pyramid hip, combination, shed type, slat box, M shape, dash gable, hexagonal. So most of the roofs are construction in different types. So these are the types of roofs. And next, lintels and arches. A lintel is a horizontal structural beam structural beams spanning across opening like doors and windows, designed to support the weight of the masonry above and transfer it to the side walls. These crucial elements prevent wall cracking or collapsing and are commonly made of concrete, steel, stone, or brick. An arch in civil engineering is a curved vertical structural member designed to span an opening such as doorway, bridges, or window. While supporting heavy loads from above, it works by transfer the vertical loads into compression forces which are distributed outward to supporting piers or abutments. So this is the arch diagram. So arches are mostly we are seeing historical places like Charminar, Golconda. Uh, the constructions are mostly constructed the archetype structures are available. So here S is the span, L is the span, outer abutments, and crown is called crown, extras, depth, inroads. So this is a arch diagram. And lintel. Lintel, what is lintel? Above the ground level 2 meters is called lintel. So this is lintel. This is ground level floor. This is wall lintel. So lintel is one of the horizontal member. Next, walls. A wall is a wall is a vertical structural element that defines, divides, or encloses spaces, providing support for loads, security, and protection from elements. Walls can be load bearing or non load bearing typically constructed from materials like masonry, concrete, and stones. So here types of walls: load bearing walls, non-loading bearing walls, shear walls, retaining walls, panel walls. Load bearing walls, crucial structural elements that transfer the weight, roofs, and floors down to the foundation after built from masonry or concrete. Non-load bearing walls, used to divide interior spaces into rooms and only support their own weight. Shear walls, specialized reinforced walls designed to resist lateral forces from wind and earthquakes, ensuring structural stability. Retaining walls, engineered to retain soil, water, and different levels on either side, preventing erosion and landslide. Panel walls, non-loading bearing exteriors walls supported by the structural frame. Next, staircase. Staircase is nothing but steps. A staircase is a structural component in civil engineering designed to provide vertical pedestrian access between different floor levels, consisting of a series of steps, flights, and intermediate landings. They allow for safe, comfortable movement and are designed with specific rise, thread, and headroom constraints. So, steps. See. Here, staircases. It is called rise, it is called thread, it's called flight. Step equal to riser plus thread. Step 1 step equal to thread plus riser. So, mostly common types of staircases. Straight staircases, a singular continuous straight flight. Like only single flight is there, it's called straight stairs. Dog-legged staircases, two flights running in opposite direction, like this. Opposite direction, one landing, it's called landing. Next, helical stairs, steps that wind around the central column. One column is there, around the steps are there. L-shaped, U-shaped stair, quaterner, or off-turn stairs, often used for space efficiency. What is thread? The horizontal top surface of the step where you place your feet is called thread. Riser, the vertical board forming the face of the step is called riser. Flight, the continuous series of steps without any landing is called flight. Landing, a flat platform between flights used for the resting, changing direction. So this is called landing. These are the steps. Here also steps. This place is called landing. Stringer, the inclined structural members support the steps on the sides. Handrail, bluster, the safety features rail and vertical ports for support. These are the handrail for holding purpose, supporting purpose we are using. Nosing, the edge of the thread that projection over the rise. Thank you.